Student, in math second, last period we learn about Pythagoras theorem. In Pythagoras theorem, some points, in these points, Pythagoras theorem, Pythagoras triplets, properties of right angle triangles with the angles with 30, 60 and 90, 45, 45 and 90, and we study about similarity and right angle triangle and theorem of geometric mean. In this period, we study about Pythagoras theorem. We know in a right angle triangle, the square of hypotenuse is equal to the sum of the squares of remaining two sides. Means in a right angle triangle, square of hypotenuse is equal to the sum of the square of remaining two sides. This is theorem. For this theorem, we write first given. In this given triangle ABC, angle ABC is a right angle triangle. Given in a triangle ABC, angle ABC is equal to 90 degree. And to prove hypotenuse square means AC square is equal to AB square plus BC square. For this theorem, there is a constructions. Draw perpendicular segment BD on side AC. Means draw segment BD on hypotenuse AC. This is constructions. Write these constructions below to prove. Then proof. For this proof, we start in a right angle triangle ABC. Segment BD is a perpendicular to hypotenuse AC. Means in triangle ABC, draw segment BD perpendicular to hypotenuse AC. This is constructions. Then we study about the theorem of right angle triangles and similarity and right angle triangle theorem. In this right angle triangle and similarity, triangle ABC, similar triangle ADB, similar triangle BDC. For these three triangles, suppose this angle is A, then this angle is also small circle, and value of this angle is a cross. Then we write the measure of this angle is also cross. If we write in triangle ABC, draw segment BD perpendicular to hypotenuse AC, then triangle ABC means there is one-to-one correspondency, circle, perpendicular and cross. In this name, triangle A is a circle, B is right angle, and C is a cross. Similar triangle. In this triangle, small triangle, we take first A, then this is the right angle D, and last is B. Similar triangle, in this small triangle, first circle is B, D and C. This is similarity of right angle triangle. If we take two pairs of this triangle, in this pair we take AB upon AD is equal to AC upon AB. If we take cross multiplications, AB into AB is AB square is equal to AC into AD. This is first. And second pair, we take triangle ABC, similar triangle BDC. Then in this pair, we take corresponding sides, means BC upon DC is equal to, we take AC upon BC. This is corresponding sides. If we take cross multiplications, BC square is equal to AC into DC. This is second. This is to prove, this prove there is AB square and BC square. If we take additions of 1 and 2, adding 1 and 2, we get AB square plus BC square is equal to AC into AD plus value of BC square is AC into DC. There is common AC in bracket AD plus DC. AC in bracket AD plus DC, value of AD plus DC is AC, means A dash D dash C. AC into AC is AC square. Therefore, to prove AC square is equal to AB square plus BC square. This is Pythagoras theorem. In Pythagoras theorem, the square of hypotenuse is equal to the sum of the square of remaining two sides. Means AC square is equal to AB square plus BC square. For this proof, there is converse of Pythagoras theorem. In a triangle, if the square of one side is equal to the sum of the square of remaining two sides, then the triangle is a right angle triangle. This is theorem, and there is a converse of Pythagoras theorem. For the converse of Pythagoras theorem, in a triangle, the square of one sets is equal to the sum of the square of the remaining two sets. For this converse, we take any triangle. Converse of Pythagoras theorem, in a triangle, if the square of one set is equal to the sum of the square of remaining two sets, then the triangle is a right angle triangle. For this converse, we take triangle ABC. In this triangle ABC, the square of one sides means to given, for given triangle ABC, AC square in a triangle ABC, AC square is equal to AB square plus BC square. This is given, means square of one side is equal to the sum of the square of remaining two sides, then the triangle is a right angle triangle. Means in this triangle, square of one side is AC square, then the sum of the square of remaining two sides, sum of the square of remaining two sides means AB square plus BC square. Then to prove, triangle ABC is a right angle triangle, or angle ABC is equal to 90 degree. For this converse of Pythagoras theorem, there is one constructions. Draw triangle PQR such that PQ is equal to AB and QR is equal to BC, and angle PQR is right angle triangle. For the constructions, you draw another triangle ABC, another triangle PQR. In this PQR, we take QR is equal to BC, and this is right angle triangle. In this right angle triangle, angle Q is 90 degree. Means you write these constructions. Drawn triangle PQR. In PQR, PQ is equal to AB or AB is equal to PQ. BC is equal to QR. And angle PQR is 90 degree. Then how to prove? In this proof, you write in a triangle PQR. In triangle PQR, PR square is equal to PQ square plus QR square by Pythagoras theorem. By Pythagoras theorem. Then we write value of PQ is AB square and QR is BC square. This is construction. Therefore, PR square is equal to AB square plus BC square. In given, the value of AB square plus BC square is AC square. From given, taking square root, PR is equal to AC. Therefore, triangle ABC congruent triangle PQR by yes test. By yes test. Therefore, we write angle ABC is equal to angle PQR is equal to 90 degree. Because Q is 90 degree, therefore B is also 90 degree. This is a proof of converse of Pythagoras theorem. In converse of Pythagoras theorem, in a triangle, if the square of one side is equal to the sum of the square of remaining two sides, then the triangle is a right angle triangle. Then we study about practice set 2.1. In 2.1, there are some examples related with Pythagoras triplets, geometric mean, Pythagoras theorem, converse of Pythagoras theorem. Practice set 2.1. In 2.1, there are some examples. For example, first is identify with reason which of the following are Pythagoras triplets: 3, 5, 4. There are three numbers. The larger number is 5. 5 square is 25. And remaining two sides, square of the remaining two sides, and sum of the square of remaining two sides is 3 square plus 4 square is 9 plus 60 is also 25. Therefore, 5 square is equal to 3 square plus 4 square. Value of 5 square is 25. And sum of the square of remaining two numbers or sides is 3 square plus 4 square is also 25. Therefore, 3, 5 and 4. This is Pythagorean triplets. Then the value of 5, 12 and 30. 13. 5, 12 and 13. There are three numbers. Square of 13 is 169. This is 1. And 5 square plus 12 square is 25 plus 144 is equal to also 125. This is second. The value is 169. This is Pythagorean triplets. Means 5, 12 and 13. 13s are Pythagorean triplets. In second example, some values are given and also figure is also given. In this figure, there is a right angle triangle. In a right angle triangle MNP, angle MNP is 90 degree. This is question number 2. For question number 2, angle MNP is a right angle triangle. This is right angle triangle and there is perpendicular NQ on hypotenuse MP. The value of MQ is given 9, QP is 6, and find the value of QP. NQ. Value of NQ is equal to, find the value of NQ. In this right angle triangle, MNP angle N is equal to 90 degree and segment NQ is a perpendicular on hypotenuse NP. Therefore, by geometric mean, theorem of geometric mean, NQ square is equal to MQ into QP. Put the value of MQ and QP. NQ square is equal to 9 into 6. NQ square is equal to 36. Taking square root, NQ is equal to 6 unit. This is second example. In third example, same as to example number 2 or question number 2, there is also right angle triangle and segment PM perpendicular on segment QR. Thank you.